In this video, we will continue exploring the relationships between arcs and angles in a circle. And again, it's going to come down to whether or not the vertex is at the center, on the circle, in the circle, or outside of the circle. If the vertex is at the center, the angle equals the arc. If it's on the circle, the angle is half the arc, or you could say the arc is double the angle. If the vertex is in the circle, the angle equals arc plus arc divided by 2. And I'm talking about these two arcs right here. If the vertex is outside the circle, the angle is arc minus arc divided by 2. And it has to be the big arc minus the small arc. All right, problem number 5, part A. Jack, can you give me the equation relating these two numbers right here?
2 parentheses 8x plus 5 equals 170.
Correct. All right, remember, this angle is on the circle. That means we have that relationship where the angle is half the arc, or the arc is double the angle. All right, so if we double the angle, that should equal 170. I'm just going to crank it out from there. So, a little distributive property, that's going to be 16x plus 10 is equal to 170. Subtract the 10 from both sides. So I've got 16x is equal to 160. Divide both sides by 16. X is equal to 10. Okay, Owen. Stas, I need to find the measure of arc MN, which is right here. How do I find it?
You subtract 360, 66, 170.
Correct. All right, you start subtracting from 360, so minus 66 minus 170. So that leaves 124 for MN. All right, Ashley, jumping over to B, part B. Can you give me an equation?
Is it the on equation?
It is on. Mm-hmm.
X
This is not going to help you, okay?
Oh, it's not?
So just, it's a start, but we got all these expressions. We have 10x minus 7, we have 17x plus 10, okay? So yeah, start by telling me, in general, sure, like if this is the angle and this is the arc, just in words tell me how those are related to each other. Like which is bigger?
17x.
Right, so the arc is bigger.
So would you do like 2 times 10x, whatever that is?
Mm-hmm. That's right. Okay, so let me erase these lines so you can read, and then go ahead and give me the whole equation. All right, I heard you say 2 times
10x minus 7 equals 17x plus 10.
correct. All right, the angle, the arc is double the angle. So if we have to double the angle, that should equal the arc. Ari, sweetie, head up, eyes open. So I'm just going to crank through this. If you're finished everything, don't forget. You're not finished? All right, keep working. So I'm just going to crank my way through this really quickly. All right, so this is going to be 20x minus 14 is equal to 17x plus 10. When I have a variable on both sides, I need to do some subtraction to get those together. So that's going to give me 3x minus 14 is equal to 10. All right, of course, then I would just add 14 to both sides. So that's going to give me 3x is equal to 24. So then when I divide both sides by 3, I get x is equal to 8. So I should have that. Okay, Charlie. Now they want to know the measure of arc LN, okay, which is shown here in bold. How do I find that?
You replace the x with 8.
That's exactly right. You replace the x with 8. Okay? So the expression is this 17x plus 10. So that means we have 17 times 8 plus 10. All right, so that should be 146. Okay. Karim. All right, we're on number 5, part C.
Yeah, I'm good.
All right, get ready to give me an equation. Give me an equation involving x.
62 equals 6x plus 24 plus 50 over 2.
All right, that is super close. You said plus 50, right? So since this is outside the circle, right. This is that one where it's going to be arc minus arc divided by 2. So just switch that plus to a minus, and we are back in business. So minus 50 divided by 2. When I do these problems, I like to combine like terms right away. So I have plus 24 and minus 50. So that's going to turn into minus 26. So now I have 62 is equal to 6x minus 26 over 2. Now, Stas, look at this equation I'm dealing with. Actually, let me stick with Karim for another minute. Karim, give me the next step on solving this equation.
Divide by 2.
All right, what do you get then?
Then you get 3x minus 13.
Yeah, that is allowed, okay? So let me just show this in 2 ways for a quick second. Some of you probably multiplied both sides by 2 as your next step because you've seen me solve it that way in the past. And that always works. Oh, it's a little bit off camera. If I were to multiply by 2 on both sides, that would be allowed. So that's going to give me 124 is equal to 6x minus 26. Then I would add 26 to both sides. Okay, so that's going to give me 150. And then if I divide by 6, all right, so what's 150 divided by 6? Some decimal.
25.
It's exactly 25. Well, all right, so x is 25. Now, if or I could do it the way that Karim said, and I should get the same answer. Both of these numbers happen to be divisible by 2, which is why this works. If one of these had been like a 5 or something, this method would be a little bit more messy. But I could, since they are both divisible by 2, I could go 3x minus 13 and then go from there. Add 13 to both sides. So that's 75. And then divide by 3. Okay, either way you get 25. All right, now they ask us for the measure of arc GS, which is shown right here in bold. Gio, how do I do that? How do I find GS? Yeah, we will substitute this 25 into the 6x plus 24. So that's going to become 6 times 25 plus 24. Okay, so that's 174. Okay. Stas, I need an equation for part D. Give me an equation.
Alright, 107 equals 12x plus 5 plus 20 plus 9.
Correct. This vertex is floating around inside the circle. That means we're doing arc plus arc divided by 2. Angle equals arc plus arc divided by 2. Okay? I see these like terms we've got, though. All right? The 12x and the 28x. Those have to be put together. And then later I've got the 5 and the 9. Those need to be put together. Okay, so Stas, I hear you getting ready to tell me. So give me the new numerator.
40x plus 14.
So 40x plus 14, all over 2. All right, now what do you do?
Now you multiply by 2.
Okay, so we could multiply both sides by 2.
You get 214 as your utility.
Okay,
40x plus 14. Minus 14 minus 14. It's 200. And then divide by 40.
okay, so we get x is equal to 5. Okay, so this is interesting. Now they want us to find arc BV, which is not one of the ones I have an expression for. Okay, arc BV is way out here. All right. Thomas? He says, let's start by plugging 5 into 12x plus 5. Okay, so if I do that, so if I do, okay, so if I have 12 times 5 plus 5, that tells us that this arc is 65. That comes out to be 65. And then just subtract from 180, because this is a semicircle. So what does that come out to be, Thomas? So this comes out to be 115. All right, again, because we did 180 minus that 65. All right, so it was 115. Owen, I'm gonna need your help on this one. Okay, we are on, I guess it's number 5, part E. Can you give me an equation? Can you give me an equation involving x? Okay, can you tell me the relationship? See, we have a quadrilateral inscribed in the circle. Do you know the rule that, that comes into play whenever we have a quadrilateral in a circle? There's like a little rule about it. All right, the opposite angles are going to be supplementary. Okay, so in other words, this angle, for example, and this angle, those have to be supplementary. So anytime you have a quadrilateral inscribed in a circle, meaning all the corners are touching the circle, opposite angle supplementary. So with that hint, can you now give me an equation?
5x plus 12 plus 9x equals 180.
Correct. Okay, these have to add up to 180. So combining like terms, we've got the 5x and the 9x. So, okay, what next? Subtract 12. So now what do I have? Okay, and then what?
Divide 14,568.
All right, and then what do I get? Oh, can somebody just tell me the answer to this? He doesn't have his calculator right now. 12. So x is 12. So then they want us to find arc VLM. Let's take a look at that. Clean this up. So arc VLM. Can somebody walk me through how I can find this yellow arc? Slade?
Alright, what I did is I knew that we have X for the 8, so I kind of did like what is it called? The one where you like multiply it by 2.
That's right. Inscribed angle.
Yeah, so I looked for the inscribed angle, because we're given that one already, and I got 192. Because I did 8x times 12, which gives us 96, and then I multiplied it by 2 to get the inscribed angle.
Okay. So Slade says since the x is 12, we can go ahead and substitute that in. So that was going to be 8 times 12. And that was 96. All right, so that told us that this inscribed angle on the circle is 96. So he doubled it because that's how you get the arc. And then what was that again?
192.
So that's why the arc was 192. 192. Okay. All right, Ashley, be ready. This kind of reminds me of the last problem we worked on together earlier in the class. Okay, we need to find x. Let me just open it up to you first. Do you have any ideas about how I'm going to find x, or should I give you a hint?
Subtract, because you need to find the one side of the triangle, right? So you subtract.
Well, I sort of know right away we should, and this will remind you of the one I talked to you about before. We should know what this angle is, like right now. And remember, like I went through the whole front, it's 90. Now, flashback. Why? Why is it 90? How do I know for sure that it's 90?
It's like matches up with the center.
That's right. Okay. I hear you mentioning the center. We're talking about that diameter right here. That makes this arc right here a 180. And then this is that inscribed angle that's on the circle, so that has to be half. Okay? So, the bottom line of all that gibberish was that we know that this angle is 90. All right, so can you see that this makes its own little tiny equation then?
Yeah.
Okay, so now I have 20x is equal to 90. So then what do I do?
Divide by 20 on both sides.
Divide by 20 on both sides. One more time. 4.5. Okay, so x is 4.5. How do I get arc VH? See, where is that arc VH? All right, for the last thing they want us to find arc WH. Arc WH is right here. Now, to figure that out, we need to know what angle Y is. Okay, so focus your eyes on that. Here's angle Y, going like this. Okay, now we should be able to find this pretty easily though. We already know that this angle at the top is 90. So we got this triangle. In a triangle, all of the angles have to add up to 180. So I've already got 90. that means if I subtract from 180, all right, so I've got 180 minus 90, which of course will be 90, and then minus 24. That leaves 66 degrees for this angle right here. Now that angle is on the circle. So as we know from these formulas, if the vertex is on the circle, the arc is double the angle. The angle is half the arc. So I need to double this. Okay, so this is going to be 132. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.